Our next presenter is David Ingus. Hope I didn't butcher that name, David, from Rocco, joining us from New Zealand. And the next four presenters will all be from the New Zealand, Australia area, and three of them are startups, including David. So, David, let's see what you're up to down there with Rocco, if you're ready.
Thanks for that. Thanks, appreciate the opportunity today to meet the team. So, yep, David and the co-founder and CEO of Rocos. And am I sharing on my side, or have you got the presentation up on there?
We have the deck on our side. If you just indicate, let us know by sound when to move the slides, we're good.
Okay, sounds good. As mentioned, we're a New Zealand startup. We work in a range of sectors, including agri-tech, and today it's really looking into the evolution of robotic operations and how it's not just a question of the robot selection and the capability of the robots, but going forward, how do you scale the robot operations? How do you manage them both in the field, but also from a centralized point? So I'm going to just cover off some of the ecosystem that's involved and where the industry is heading and the type of work that we're doing in that. Appreciate going to the next slide. Just a quick summary of the three areas we really focus on. We focus on connectivity of robots, and that's both connectivity of the robot to a centralized system, which is often run in the cloud. And that can be the robot back at head office, or it could be from the field. But the connectivity also includes connectivity with operators on a local connection where there is not cloud connectivity in that environment. And a lot of the work around that too includes very heavy investment in security protocols. Because once you've got robots connected into cloud infrastructure, it's ensuring that they're protected assets. Secondly, it's around monitoring. So how you keep an eye on the actual work, the jobs that the robots are carrying out. And there's various interested parties from head office operators, making sure the jobs are doing the work that they're intended to do, but also down to the mechatronics engineers being able to diagnose problems in the field from that remote location. And the third area is really around the concept of control. And control has two aspects. One is designing the jobs for the robots to do and coordinating the fleet of various types of robots live in the field. And secondly, it's around intervention. So if a robot has a problem in the field, a remote operator can take teleoperated control of that robot and get it out of that situation when required. If we go to the next slide. In terms of the ecosystem, probably best just to press the button a few times here. You really have, firstly, the robotic providers that are providing the capability of the physical automation in the field. And on the hardware side for the robotics includes the autonomy stack. So the work that the robot can autonomously carry out, which could be mowing, fertilizing, weeding, picking, all of those various aspects. And of course, you may have more than one robot and more than one robot type in that orchestration. So increasingly, we're starting to work with organizations that have multiple robot types, and those robots have to actually interact in those types of scenarios. On top of that, it's about platforms like ours, which is around scaling. So really, how do you connect all of those robots carrying out the jobs into a centralized system and have one central view of all of the work that's taking place? And we have views which are based on what we call personas for the people interested in managing those robots. You might have a view which is on a ruggedized tablet in the field connecting directly to the robot. You might have an enterprise view, which is all of the robots in all of the farms that, in the whole country that you're actually operating in. And the types of capabilities in the robotics operations system you're interested in is things like you store things like the infrastructure data. So if you have fruit environments, you may have GPS coordinates for posts, from which you can build things like missions, which can be sent to the robot. So effectively, you capture digital twin information about the environments, the GPS data, and that in turn allows you to do things like designing the work that the robots need to do. It includes things like fleet control, so sending those missions down to the robots and the coordination between them, mission management, which is individual robot mission design and pushing that mission effectively down to the robot. And also in reverse, it's collecting data off of the robots. And this needs to work both live, so if you have live connectivity, but also in a cached format. So when the robots collect data in the field, if they later on are then brought back to internet coverage, it can then synchronize that data. And that, for example, might be for a lab in the field type of scenario, or simply diagnostics data on how well those robots are performing. You also have IoT providers, which is quite a different set of technology. Generally, the IoT devices don't get updates to their missions. It might be a weather station. It's collecting a generic set of data, which is continuously pushed up to an IoT system. And then, of course, the business intelligence system is trying to gather the data from things like the robotic operations platform and the IoT system in order to give higher order optimization. You might be looking at farm health, you might be looking at moisture mapping, applying machine learning to make better decisions for the work that you're doing. If we go to the next slide, just shows really an example of this ecosystem. So firstly, you've got the robot provider. In this case, you might have a ClearPath robot. It may have a set of sensors on it. It has a set of autonomy in terms of being able to be told at a GPS location where to go to. But ultimately, something has to tell that robot all the different waypoints and actually design the path plan for that robot, tell the sensors when to capture what type of data. And there might be multiple sensors, multiple camera types, LiDAR systems, moisture sensors, all of those types of things could be on the device. So the robotic operations platform is intended to tell that robot where to go and what to do. And that can be done at scale. It can also pre-capture that mission, and it can give it to any new type of robot. So we might use a ClearPath robot today, and we might introduce a different robot next year, but the same mission is actually sent to the robot, and we translate that mission into the language that robot speaks. So it avoids vendor lock-in for the farmers, and they can actually choose a range of robots as the evolution of the robots take place, plus the fact that we can communicate with very different types of robots at the same time. Your IoT stack might be something like Microsoft IoT connected to the weather station, and then your business intelligence system might be something like a farm beat. So that's just an example of what an ecosystem could look like with an integrated system. Go to the next slide. This is just an example of what a view might look like. This is just showing the Bay of Plenty in New Zealand. You may have some kiwi fruit orchards. You may be collecting some sensor data from having the lab in the field in those environments. In the system, you can see the robots, you can see the health of the robots, you can see if they're currently connected, what jobs have been scheduled. You may have the assets in terms of the orchards, the sizes, the GPS information is stored in the centralized system, which means it's very easy for an in-field operator or a remote operator to design a specific mission that needs to be carried out. That could be pre-sent to the robot, so somebody could literally deliver the robot, it could roll off the truck and immediately execute its mission, or if the robot actually lives in that environment, it could wake up, execute the mission, and go back to a docking station automatically. And then, of course, you're tracking the information that's coming off these environments. And in systems like this, it's all about being very, very highly configurable. It's easy to integrate the data with third-party systems, and it's easy to change the visualizations of managing the various type of crop that you have. If we go to the next slide, this is just a representation of, you might have that ruggedized device. It's not necessary to have cloud connectivity all the time for the robots. You may need a local connection. The same application can be used remotely, whereas when you've lost connectivity from the cloud, it can be used locally to connect directly with the robot. You can see the mission that's been organized. You can edit the mission and actually have that robot carry out. Plus, you can get that diagnostic data back. And this is important that that mission, if it's edited by the person in the field based on a change of environment or an inaccurate development of the mission, that can be synchronized so that next time that same action has to be taken, it's now optimized and goes from there. If we hit the next slide, the kind of areas that we do a lot of work in is a question around where should we start in the environment. So it's really, we look at organizations and what parts of the operation can actually be automated. And there's many areas that are growing. And next, it's about really identifying the robots that are capable of doing that work. And of course, there's also capturing data. So capturing satellite imagery, photogrammetry imagery, capturing GPS information, which becomes the heart of the ability to design these missions. And then it's about selecting a wide range of robots to carry out the various activity, and the system can then coordinate those robots from that central system. So I hope that gives people a quick overview of really, where the scaling in robotics is heading, and the types of systems that you're likely to be implementing, over the next years. Thanks a lot.
David, thank you. That is a great overview. And as you might guess, I really love to see the ClearPath, Microsoft FarmBeats, and IoT. That's exactly the approach we've been advocating for all day. So great to see you using some standard components and some modular architecture to build that out faster. So congrats on Rocos.